Hi guys, and welcome back. In this video, we will be doing a deep dive into the Sheffield Floods of 2007 case study. This is an essential part of the specification for river flooding and management in the UK, and I have broken it down in a way that makes it easy to access the relevant information and remember it for the exam. I would also advise that you make some notes as we go through the case study and possibly flashcards later. Okay, let's get started. I have divided the case study into four main questions to make it easier to access. And the first question is where? And we are going to be looking at Sheffield's location in the UK and have some background information so that we can get some kind of context for the case study. Then we are going to look at the why. So why did the flood occur? And we will be looking at physical causes and human causes of the flood event. Then the what happened, what were the impacts, so the economic impacts as well as the human impacts of the flood event. And then lastly, we'll look at the how, and that is how did Sheffield respond? What management strategies were in place? So before the flood, what management strategies were there? And then what strategies were used during the flood? And finally, what kind of strategies were used to prevent future floods from taking place or from causing a lot of damage? Okay, so let's move on then to the first one, which is the where. Sheffield is a northern city of the UK, as you can see here, and it is in South Yorkshire County. It was well known in the past as a steel city, and that was during the Industrial Revolution due to its innovative steel making processes. Now, most northern cities in the UK at the time, or a lot of them really, developed as coal mining based cities. So they were based on the primary sector of industry, and a lot of them mined coal. That coal was then used in steel manufacturing, because in the steel manufacturing process, you need coal, which means that it made sense to locate the steel industries near the coal mine so that you don't have to transport it far to get it to the steel manufacturing factory or industry. So that is what Sheffield started off as. But as we know, after the Industrial Revolution, a lot of these northern cities experienced or suffered a period of economic decline, because a lot of the steel manufacturing, actually the steel industry, closed down or shut down, and as the coal mines were closed as well. So that meant that they had to transition the economies from economies that were based on the primary sector of industry, which was mining, to new industries such as retail, finance, and banking. So Sheffield is one of those towns that experienced those changes. Now, coming back to flooding in the UK now, we are going to talk about it in the UK context before we go to Sheffield specifically. And in 2007, there was widespread flooding across the UK. And it was caused by record-breaking rainfall between May and July of that year. It was the wettest May to July since 1766, which is 241 years prior. Okay, so it led to extensive river and surface water flooding, particularly in southern England, in Yorkshire, obviously where Sheffield is, and the Midlands. Across the UK, the cost of damage was an estimated £4 billion, with about $3 billion pounds, not dollars this time around, in insured losses. So as you can see, there was quite a lot of economic impact on the country, but this here is countrywide, not Sheffield. And it led to the rescue of 7,000 people across the country and the displacement of 17,000 families from their homes. 13 deaths were also reported across the country, so countrywide. Okay, let's move on to Sheffield and see what specifically happened in Sheffield. Okay, so we are now going to move on to the why. So why did the flood occur in Sheffield? And we will start off with the physical causes of the floods. And the first one is antecedent rainfall. Now, antecedent rainfall is the rain that has fallen recently. and over 90 millimeters of rain fell in 48 hours around the 15th of June. This was a month's worth of rainfall, leading to very saturated soils. Now, that means that because there was so much rain, within only 2 days, you had worth that was a month's worth of rain. So that's a lot of water to fall in the area within a short period of time. And the soils would not allow that water to infiltrate quickly enough, obviously, because it's too much water. And then on top of that, you have that water not being able to drain away from the area quickly enough through the rivers and so on, because there's infiltration, there's surface runoff, there's groundwater and so on. So as a result of this water not draining away quickly, the soils were fairly saturated. And then 10 days later, after the 15th of June, so this is now the 25th of June, Sheffield experienced another 100 millimeters of rainfall in just one day. Now, that clearly was a problem because it meant that the saturated soils were now, they were already full of water. They couldn't take any more water. And now they have another 1 month's worth of rainfall to deal with. So they could not cope. And it was not just, it was the urban drainage systems and the rivers in Sheffield, in and around Sheffield, that were completely unable to cope, and therefore there was widespread flooding. In fact, one of the reports say that at one of the stadiums, the Hillsborough Stadium, the water levels went up to around 8 to 9 meters, which is really, really high. So antecedent rainfall is rainfall that has fallen recently, and that has an impact on flooding. It's a physical cause of flooding because the soils are saturated and cannot handle any more water, and therefore flooding is likely to take place. So the second physical cause that we are going to discuss here is the relief or topography of Sheffield. And we know that relief or topography is the shape of the land or the height of the land. And Sheffield is famously described as being built on 7 hills. Some argue that it's 8 hills, but then it's famously known for 7 hills. So we will just stick to the 7 for now. So some of the ridge lines for those hills are shown in the diagram here. So if you look at this diagram here, map, excuse me, it's a map. So you have the ridge lines here. So Dykes Hole Road, for example, is a ridge line, and a ridge line is basically a ridge. Obviously is a raised area, so one of the hills, and then the ridge line is where the water will quickly flow down to due to the force of due to gravity, and then find its way towards Sheffield. So you have several ridge lines here, as you can see, and all of them seem to be going towards Sheffield. Okay, so in fact, let's just discuss that. And that's because Sheffield is actually the confluence of 3 main rivers. Those rivers being River Don, River Rivelin, and River Loxley, which is not necessarily here, but those are the 3 main rivers in the area. But as you can see, there are other rivers there as well, which are now smaller tributaries, so not necessarily as big as the other 3. So you have River Sheaf, and you also have River Porter. So there's a lot of water in and around Sheffield, and we know that that is also a physical cause of the flood. The fact that Sheffield is located at the confluence of 3 rivers. That, combined with the relief or the topography of the land, and then the other thing is that Sheffield is right at the bottom of it. So it's actually the floodplain where all the water is coming to meet. Okay, so some of the ridgelines for those hills are shown on the diagram here. We've talked about that. Sheffield has a bowl-shaped geography and is at the foot of the Pennines, right at the bottom. So like we've said, it's the floodplain. Okay, so that then means that the river is going to converge very rapidly in Sheffield and then into the city center. Okay. What were the human causes of the floods in Sheffield? So the first one we'll start off with is that Sheffield is heavily urbanized. Now, we mentioned on the last slide that Sheffield is at the foot of the Pennines, which then implies that the area around there is fairly flat, which is then easy to build on. And if it's easy to build on, it means that that is the reason why Sheffield started off as a settlement at this particular location. And over time, Sheffield grew through the Industrial Revolution and then up to now as the population continues to grow. So it's quite a large settlement now. And that means that it has a lot of houses, and other buildings and infrastructure. And when you have buildings and infrastructure, such as, roads which are made of tarmac, then it means that infiltration rates are reduced. And if the infiltration rates are reduced, it means that water will tend to sit on the surface other than sink into the soil. And that causes flood risk, or it increases the risk of flooding. Now, this was one of the reasons why Sheffield flooded, because the water could not sink into the soil. And then the second reason is that there was poor drainage as well. The drainage systems in Sheffield could not cope either. And the Sheffield drains actually were built for a 1 in a 30-year event. Now, this here, like we discussed in the previous slide, this flood event in Sheffield in 2007 was, such an event had not happened in 241 years. And in this particular case, it was a 1 in 400 years event. And it caused the drains to be overwhelmed by the amount of water that was racing down Sheffield's hills. And on top of that, the drains also got blocked by the debris that was coming in, from the flood waters. So that would include things like leaves, small branches, mud, and silt and so on. That causes the drains to become clogged up, and therefore the water sits on the surface other than drain away. Then on top of that again, the rivers as well had trees fall and block them. If trees are fallen and block the rivers, then it means that the rivers cannot drain the water away quickly enough, which means that then those rivers overflow, and they overflow onto the surrounding area, which is a floodplain and which Sheffield is. So the water levels just keep going higher and higher. And I think I had mentioned that Hillsborough Stadium, which is in one of the pictures here, ended up with water levels that were around 8 to 9 meters. And that is as a result of the water, building up due to the heavy urbanization and the poor drainage. So those are the two first human causes that we'll discuss. The third one is poor flood defenses. Now, the flood defenses as well, gave in to the amount of water that was coming in, either because they were breached, or as in they broke basically, or that the water levels were too high for them. They were higher than the flood defenses. So if there's a flood wall and the water rises to a level that is higher than them, obviously it will not be able to cope with that water or block that water from going into the surrounding area. And Meadowhall Shopping Center, for example, had defenses to protect it against a 1 in a 100-year event. But like we've said, this was a 1 in 400 years event, and therefore the defenses were not good enough, and therefore the area ended up flooding. Now, the other thing that I've put here is the flood hydrograph, and I'd like to quickly discuss it in the context of Sheffield's. Now, and in the context also of human causes of flooding. Now, when an area is urbanized, you will have a flood hydrograph that will rise very steeply. So if the rainfall event is going to be here, so the bars for the rainfall should ideally be here on this flood hydrograph. But this particular one does not have, the rainfall event, but they should be here. Now, that then means that the water from the rain is going to reach the river. Because the flood hydrograph shows the amount of water in the river at a given time, and that is normally represented in cubic, so in cubic meters per second. So you can see that in an urbanized area, which is represented by the solid line, the water reaches the river very fast. You can see the level of water in the river is rising rapidly. It's a very steep rise, and then it gets to a high peak. and the normal flow of the water should be around here. So that's a base flow of the water. So if it rises beyond that base flow of the water, or yes, base level of the water flow, then the river will be in flood. And as you can see here, urbanized areas are more likely to flood as opposed to forested or rural areas, which are represented by the dashed line. You can see that the dashed line is a lot more gradual in terms of the water reaching the river, and then does not get to a high peak, and therefore that river is likely not to flood. But an urbanized area is likely to flood. So this is another component that you could bring into your explanation if you are explaining this in the exam, and explaining why heavily urbanized, or urban areas rather, like Sheffield, are more likely to flood than rural areas. So it's because they are heavily urbanized, there's not much infiltration or interception, and then the other causes as well that we mentioned here would be good to use in conjunction with this flood hydrograph here. Okay. On to the what. So what happened and what were the impacts? Now I've divided them into the human impacts and the economic impacts. And the human impacts are shown in green, and we shall go through them one by one. So the first one is that unfortunately there were 2 fatalities. So 2 people died in the Sheffield floods. And then in terms of how health was affected, people's health was affected, the raw sewage flooded onto the streets and homes, posing a health risk. Now we know that flood waters is likely to go into the sewage system as well, and then everything just comes out to the surface. So that presented a health risk for people living in Sheffield. Then we have power outages. Now, as when you have a big flood, trees are likely to be uprooted and so on, and power lines as well. So that led to power outages, and 13,000 homes lost power for at least 2 days. Now, if you think about, anyway, we'll get to that when we get to the economic part of it, but that was as far as this being a social impact is concerned, or a human impact. Okay, then we have displacement. As we said earlier, a lot of people were displaced. Hundreds of people had to be evacuated from their homes, and they, obviously had no use of their home. They could not use their homes, and had to be either rehoused or to put into some kind of temporary accommodation in the meantime, while a more permanent accommodation was found for them. All right, then we had also, unfortunately, mental trauma that people suffered due to the mental toil that the flood took on them during this particular event and in its aftermath. Okay, so moving on then to the economic impact, and these are the ones that have to do with the economy or have to do with money. And the first one is that there was property damage. So over 1,200 homes and then 1,000 businesses were flooded or affected. Now that meant that these homes needed to be rebuilt or, restored, if you like. And then the businesses also had to, the same had to be done for the businesses as well. So that means that a lot of money was needed to do this, and that's why it's an economic damage. Then you have closures. Meadowhall Shopping Center, we said, was flooded, had flood waters inside, and therefore it had to close for a week. So that's a loss of business for the businesses that operate within that shopping mall, which meant that there was a loss of income for them, and therefore for the greater economy as well. Then we have insurance costs. So some of the residents faced increased insurance premiums or difficulties obtaining new coverage. Now, because of the flood event and because of the kind of payouts that these insurance companies ended up paying to people and to businesses for that matter, they were now a lot more hesitant to provide insurance coverage for people living in Sheffield, because to them, Sheffield now is a high risk area, and therefore if they insure people here, then they may have to pay out a lot in the future. So they were hesitant to take on new people for as customers for insurance from Sheffield. And then on top of that, the people who already had insurance had their premiums go up. So the payments they would make on those insurance policies went up because of the high risk that now Sheffield posed as a place to live. Then we have infrastructure. So, for example, infrastructure damage. So, Hillsborough Stadium, we've mentioned, had millions of pounds worth of flood damage, which then had to be restored, and that obviously cost that money. And then we had business loss. So companies such as Clarkson Osborne, and this is not the only company, obviously, experienced substantial financial loss. And this particular company experienced a loss of £15 million, which is a significant amount of money. And especially considering that it was not the only business that was affected. There were others that were affected as well. So the total tally, obviously, just kept on going up. Onto the house. So how did Sheffield respond? What were the management strategies? Now we have two main types of strategies here, management strategies. The first one being hard engineering. And hard engineering is where you put up physical structures to protect an area from flooding. So actual physical structures. So an example being a flood wall. So you build a concrete wall so that it can block the water from coming into the built up area and flooding it or inundating it with water. Then we have soft engineering methods, and those ones are where you try to work with nature, where you don't necessarily use physical structures, but you're working with nature to try and control or regulate water in an area so as to reduce the flood risk in that particular area. So we are going to start off with the hard engineering methods and just talk through them. And the first one that is used in Sheffield and that was improved after these particular floods is flood walls. So this involves building walls alongside the rivers to increase their holding capacity. So if you build up a wall around the river, then that means that in times when you have a lot more rainfall, the river will be able to hold a lot more water. So you'll have increased the capacity of the river, and therefore flooding will be the flood risk will be greatly reduced. Excuse me. And an example of that is the Upper Don Flood Alleviation Scheme. And this was put in place after this particular flood. And if we are talking about a flood alleviation scheme, it's a scheme where they are trying to get rid of that particular flood risk. And this one is particularly in the upper part of the Don River, or the River Don rather. Okay, so what are the benefits? So it's cheap and it's suitable for city centers. Okay, because city centers are the ones that require the most protection. And then if we think about it as well, in terms of cost-benefit analysis, the city centers are worth a lot more, so they are worth protecting, and therefore it justifies the cost of putting flood walls up to protect them. Okay, then the limitation is that they move water very fast from this area, because the water now will collect in the river and then drain through the river. So they will move water from this particular area and move it further down, downstream rather, and they are likely to cause flooding elsewhere or further downstream if those other places downstream are not protected. So it solves a problem in one part of the river but may increase the flood risk in another part of the river. Okay, then moving on to dredging. And dredging is where you remove excess sediment from the river. So you dig it out. And a lot of times when you do the dredging, you will remove the sediment and then place it on the side, on the river banks. So by placing it on the river banks, you're actually creating a barrier between the floodplain and the river channel, which means that with those raised embankments, you also have some kind of protection from the river, because the river water will have to rise to a higher level to be able to get over those embankments and then, those naturally raised embankments and then get onto the floodplain. And then you are also increasing the river's holding capacity, because you have dug the river channel and remove that excess sediment, so the river is capable of holding a lot more water, and therefore you're reducing flood risk. But then again, this can also increase flood risk elsewhere, because you are causing the water to build up within the river channel itself and then drain away from the area very quickly, and it's a lot of water. So downstream, if other areas are not protected, they are also likely to get flooded. Okay, and then the benefit is that it can be done regularly, and it's quite natural. Now, okay, so the next one is levees, and levees are raised embankments to increase river capacity. And they are similar to what I was explaining about the dredged material being put on the riverbanks. So the levees is where you are raising the river banks, and those are referred to as raised embankments, and they increase river capacity. But the problem with them, or the limitations, is that they are expensive and they can increase the risk of flooding elsewhere. Okay, then you have diversion channels. Now, diversion channels, like the name suggests, is where you divert water from valuable areas such as the city center. So you dig out channels that take the water away from that built up area, so that it does not get to it and cause flooding there. And the benefit is that it will protect, obviously, the most valuable areas, because like the town center is where most businesses are, and it's the most valuable part of Sheffield, so you're protecting that. But the limitation again is that it can increase the flood risk downstream. Okay, so moving on to the soft engineering methods, and we said that the soft engineering methods are not necessarily building physical structures, but work with the environment or with nature to protect the area from flooding. And the first one is floodplain retention. So the level of floodplains is then lowered. So the floodplain, it's dug out and it's made a lot lower, which then means, and then vegetation is planted, which means that vegetation, so if you have trees, you have some grass, instead of just concrete, you remove the concrete, and you have trees, you have grass, and you have also lowered that floodplain. Now, by doing that, the trees, first of all, are going to intercept the raindrops. So they are going to slow down the time in which it takes for those raindrops to reach the ground. So they delay surface runoff. So that is, in a way, reducing the flood risk. And then because you no longer have concrete surfaces, or tarmac or concrete, you then will have a lot more infiltration, because the water can now sink into the soil. So because it sinks into the soil, it's going to find its way to the river a lot more slowly, because you know that there will be infiltration, and then there will be through flow. Some of the water will flow through the soil towards the river, and that's a slow process. And then the water that percolates further down and goes to the bedrock that is below will also flow as groundwater towards the river, and that again is a very slow process. So you have slowed down that process of the water getting into the river very quickly and inundating the river, or in this case, because it's Sheffield with several rivers, so it's rivers, and in this in so doing, you are decreasing the risk of flooding, and you're doing it in a natural way, because you're also restoring some kind of vegetation and beauty, restoring beautifying the area, because there are trees and so on. Okay, so the second one is river channel restoration. Now, this is where you rebuild meanders. Now, we know meanders are bends in the river. So in places where those meanders have been cut off, maybe and have become oxbow lakes or whatever, and the river is flowing in a straighter channel, you then restore those meanders. And by doing that, you lengthen the river. And if you're lengthening the river, it means that the water will flow a lot slower, because we know that if a meander is cut off, the new channel through which the river flows gets the water out of there very, very quickly. But then by restoring a meander, you slow down the process once again of the river flow, of the velocity of the water. And that obviously is going to decrease the flood risk in the area. And then banks are also lowered to allow water to flood the park instead of the city center. So in areas where you have parks, where you have natural vegetation, you lower the banks there, so that instead of the water building up and flooding areas like the city center, that water instead will flood that natural area, which is not worth a lot of money, so to speak, in terms of infrastructure and businesses and so on. And therefore, in so doing, you have reduced the risk of the damage that is likely to be caused by a flood. Okay, so trees are replaced by trees in place rather of concrete. I meant to say concrete is replaced by trees, but that we had mentioned earlier. And again, this increases the natural feel of the area and increases biodiversity. Okay, so these are the ways or management strategies that Sheffield and other places in the UK as well have put into place to reduce flood risk. That brings us to the end of the Sheffield Floods of 2007 case study. I hope that you have found the information useful. Let me know if you have any questions in the comment section below. I will also do videos on the Somerset Level and Boscastle flood case studies, and they will be in the case study playlist or come up as suggested videos on this slide. Thanks for joining in this journey towards excellent exam results. All the best and see you again soon. Bye-bye.